Hi, Algebra 2. We are going to be doing lesson 1.2 today, the introduction to parent functions. And we want to be able to identify parent functions and be able to use them to model some real world data. So here we go. First, we're going to define what a parent function is. And it's going to be the simplest function with the defining characteristics of the family. And when we talk about family, these are the names that we're going to be referring to: constant, linear, quadratic, cubic, and square root. This table, you're going to get really familiar with this table and these names throughout the semester, throughout the year. It's giving you the general shape of each function. You may remember linear functions a lot in Algebra 1 and maybe some quadratic, but these cubic, square root is going to be a little bit new for you. And down here it's going to tell you the domain and range. Remember, the domain is all of the possible x values. So going horizontally, what are the possible x values for that function? And then range is going to be all of your possible y values. So going vertically, what are all those possible y values for your function? Our first example is asking us to identify the parent function and describe what transformation is happening. Remember that a transformation is going to be how is the function moved? Is it up, down, left, right, made narrower, made wider? What's happening there? So first, looking at function g of x, I see that it's just plain old x in there. It's not x squared, it's not x cubed, it's just plain old x, which is going to tell me that this is going to be linear. And then we're going to graph it on the calculator. Feel free to use Desmos for this. And instead of g of x, I'm just going to put in y equals x minus 3. And there's my graph. You're going to want to sketch that in your notes so that you have it to refer to. You'll notice that it is going through -3 down here and on the y-axis. And in general, the function has just moved down 3 units. And we could see that if we just graph the parent function, y equals x, that's the parent function, and we can see that our new function was moved down 3 units. Our next one, we're going to be doing similar work here. We have x squared plus 5. I see the squared on my x term, and that's going to tell me that this is quadratic. And then I'm going to graph it, and I'll do y equals x squared plus 5. And there it is. If I graph the parent function, which is just y equals x squared, I can see that the transformation here is that my function was moved up 5 units. In our next example here, because of the x cubed term, this is going to be a cubic function. Here's our parent function. I did graph both of them, and we can see that it did move our parent function up 2 units. Here I've graphed the points. Some of these points go a little bit off the grid, but that's okay. And if I just sketch a line that would connect those, I start to see that it is going to be a quadratic function. In order to figure out the transformation for this function, I do need to look at what the parent function is. So I know it's quadratic, so here's my parent function, and I need some points for that to graph. So I'm taking the same x values that they did here, put those x values here, plug those in for x. So -2 squared would be +4, -1 squared would be 1, so on and so forth. I graph those, and once I make my line, I can see that my transformed function, the blue line, was made narrower. So the transformation was that it was made narrower. We'll be able to describe more about this later, but right now, all you need to know is that it was narrower. On this slide, we're talking about the 2 points 0, 0, and 0, 1. And as we see, if we plot 0, 0, and 0, 1, that's actually going to fall on lots of different parent function graphs. And so just remember that you should have definitely more than 2 points to be looking for a parent function. More is always going to be better. And that also, a parent function is just going to approximate a set of data. And that parent function doesn't necessarily have to match the data perfectly. And that's what we're going to be looking at a lot this year, is how do we model data using these parent functions. On this one, now we're looking at some more real life data, looking at years and cumulative sales. And I would label your graph first and then graph these points and start again when you're ready. All right, you've got your data plotted and you can start to see or visualize a curve being in here if you were to connect them all. And we're supposed to estimate when we reach 10 million. So looking at your graph, I would approximate a mark for the $10 million in sales to be somewhere right there. And if you see where that falls, it falls right between year 4 and 5, probably midway, maybe year, if you want to call it 4.5. Deciding what parent function would fit this best, if you were to draw a curve in there, it would fit a quadratic really nicely. You only see half of it because we're in quadrant 1, but a quadratic would fit this curve really well. Okay, in this next one, again, we have some more real life data. To label our axes, time is going to be your x-axis. It's the top row here. Cost is going to be the y-axis, the bottom row. And labeling your axes, remember that you don't necessarily have to label every line of the axes. It can keep things a little bit cleaner, so that's what I showed on this one. So plot your data and start again when you're ready. All right, once you plot your data, you're hopefully seeing a pretty linear parent function come out of that. And we want to estimate the cost of 5 months of online service. So I'm looking at 5 months on my line. It's going to fall right about there. So just a little bit over $70 it looks. Now this is just a hand-drawn graph, just kind of eyeballing my line, and this is really just an estimate, remember. Later on during the year, we're going to find ways to make much more accurate predictions based on our parent functions. Good work, you made it to the end of the video. Let me know if you have any questions. I'm here to help you, and if you're ready, move on to the next step.